from a Boeing 707, which was the largest aircraft at the time. And we are told that these massive structures were destroyed by 10,000 gallons of jet fuel, a perfectly symmetrical collapse resulting from asymmetrical damage, with the collapse following the path of greatest resistance. The National Institute of Standards and Technology, NIST, eventually concluded in August 2005 that they found no evidence suggesting that the Twin Towers were brought down in a controlled demolition. It's funny they would name it the Report on the Collapse of the Twin Towers, because the report does not explain how the Twin Towers actually collapsed, claiming that it does not actually include the structural behavior of the tower after initiation was reached and collapse became inevitable. 10,000 pages, and not a single one to actually explain how the towers came down the way they did. NIST admitted in April 2007 that they are unable to provide a full explanation of the total collapse, and also that they conducted no tests for explosive residue. Luckily, somebody has.
My name is Jeanette McKinley. I was a resident of Lower Manhattan, living directly across the street from the World Trade Center on September 11th. I'd been living there for 4 years. I loved living there. When I think back about it, it's really the time of my life. And so on September 11th, I was I was writing emails. I was sitting at my computer. Boom. I could immediately see the flames. I was close enough that I could literally just turn my head, and there it was with the building burning. I was with my friend Jim Lecce. We watched everything out the window. He was fixated taking photographs, and whenever I mentioned leaving, he never wanted to leave. He said to me, "This is history. Don't you realize we are watching history happen? We're part of history. Why would we leave?" I was in the kitchen. I was in my kitchen. I had flowers in my hand, and the building starts coming down. Our windows blew in. He came running across the apartment. "Get out of here, the building is coming down." Well, it sounded like it was coming down on us. That cloud, there was a debris cloud created by when the Tower 2 fell. It created a debris cloud which became part of our life because it just burst in our window at 50 miles an hour. That whole cloud just came bursting in, and many people were wanting to investigate whether the collapses were actually controlled demolitions, as many people thought on the very day. Even the news commentators thought they were controlled demolitions. So there was a lot of controversy about whether they were or not. And friends of mine that knew that I had the dust were also knew a scientist, Stephen Jones, at BYU.
My name is Dr. Stephen Jones. I have a PhD in physics from Vanderbilt University, 1978. I have a Bachelor of Science degree from Brigham Young University, 1973. I graduated magna cum laude. I went after the PhD work. I did postdoctoral work at Los Alamos Maison Physics Facility. In June 2007, I was examining a dust sample, which I'd obtained from Jeanette McKinley. I was using a loupe and also just looking at it with my eyes and an ordinary optical microscope, although stereo, so that I could see better in 3 dimensions. And what I found was a chip that looked like it might be a paint chip. I mean, early on I was thinking maybe not too interesting, but this chip was rather striking in its appearance. It had an orange-red color, first of all, and then I found several of these, and they all had some gray material adhering to the side of the red material. So layered. Later we found multiple layers, but most of these chips have 2 layers, red, gray. I did take one of these chips then to the electron microscope, the scanning electron microscope, and we looked at it with the electron microscope, and then we used a system where we could determine the elements. What we found in the red material is a combination of aluminum and iron oxide, and these are the components of thermite. Of course, now we looked with an electron microscope, we looked deeper and deeper, a higher and higher magnification. And I pulled in a colleague of mine, Dr. Jeffrey Ferrer. He's an expert on the electron microscope machine. So he actually broke a piece off of one of these red chips, and then later he did 4 different samples, broke a piece off. That gives you a fresh surface. Because in the dust, there's all sorts of stuff. There's zinc and titanium and calcium, all sorts of stuff. So he broke off a tip, you see, so we could look at a fresh surface. And then what you see in all 4 samples that we studied in this detail: carbon, which is significant, oxygen, iron, and aluminum. We looked at this, and these again are the ingredients, except for the carbon, and we found that experimenters working with superthermite, trying to beef it up, make it more explosive, tailoring it to different weapons applications, they would have silicon in there and an organic material, which means a carbon. So a polymer such as Viton, they would add to this to give it the properties they wanted. So that fit. Now, see, that was surprising to me to see silicon and carbon, but then we find in the literature that's what these guys are doing in the weapons labs, Livermore and Los Alamos. They're adding organic, because that gives you a gas production. When the thermite goes off, now you also have gas production, which gives you the explosive force, for instance. I suggested that we take a sample of this red-gray chip material and run it through a very sensitive instrument called a differential scanning calorimeter. And he did that. What it does, you heat the temperature slowly, and a material will react if it's going to. And if it reacts and produces heat, you'll get a spike in your calorimeter. And then if it reacts quickly, it'll be a narrow spike. If it, say, burns over a long period of time, you'll see a big broad spike. And the total area there is the total amount of energy released, and it gives you a lot of information. What we found, what Dr. Ferrer found first, and he was real excited when he told me about this, he took one of these chips and he put it in the differential scanning calorimeter, and sure enough, it went off at right about 430 centigrade, but more importantly, the peak was high, which means a lot of energy released, and narrow, which means, in his terms, it blew up. You know, you say, man, this is it. This stuff blows up. It behaves just like it has the ingredients of nanothermite. He said, well, there should be, in a thermite reaction, you should produce molten iron. So you should see some spheres of iron. Think of spraying water in the air, and you get droplets that are more or less spherical because the surface tension pulls the liquid into a sphere. It's very simple. Same thing with molten iron from the thermitic reaction, whether it's ordinary conventional thermite or this super nanothermite. Either way, you get this molten iron, and you should get these droplets of iron. So we said, we got to look for those. You know, if you don't find those, maybe who knows what it is, but we got to find droplets of molten iron. Otherwise, we're not sure we had the thermite reaction, the thermitic reaction. In this case, it's a nanothermite. So we looked, and wow, what a beautiful sight. As you look at this, after the red material is reacted, there are these little spheres, just tons of them. And we compared the traces that we got in this sophisticated calorimeter with traces obtained with known thermite. These are published data, and our peak is actually narrower. I mean, this stuff goes off with very rapidly, and more energy also than had been reported by these other researchers working with known nanothermite.
As if explosive residue in the dust was not enough, there are